Hello, and welcome to Empowered Learning. This particular lesson will be on graphing the equations of a line by plotting points. And so in particular, what we are going to talk about is the three different forms of an equation of a line, the advantage and disadvantage of using them. We're going to talk about the various types of lines that we have, lines with positive slopes, negative slopes, lines that have a zero slope, as well as lines that have an infinite or undefined slope. And then we're going to do some practice by taking some equations of lines and plotting points to figure out what their graphs would look like. So let's go ahead and get started. So we see, to start off, we have three different types of an equation of a line. And so the first type, which is the most popular, would be the slope-intercept form. We call it the slope-intercept form because that is the information that it gives us. The M gives us what the slope is, or how the graph rises or falls. And the B gives us the y-intercept, which is the point on the graph where the line crosses the y-axis. So as an example here, we see we have the equation of a line y equals negative 4x plus 2. And so if we were to plot some points here, if we let x equal 1, when we plug that in, our resulting y value would be 2. And so hence we have this point on the graph here. If we go and plug in 1, then of course 1 times negative 4 is a negative 4, and negative 4 plus 2 is a negative 2. Hence why we have this point here on the graph. Now, if we wanted to find the x-intercept, what we would do is we would let y equal 0, because as you see here for the x-intercept, this is a point that is on the x-axis, and every point that is on the x-axis has a y-coordinate of 0. So in short, x-intercepts always look like this, and y-intercepts always look like this, where we find the y-intercept, we always let x equal 0. If we find the x-intercept, we let y equal 0. Okay. Now let's go ahead and move on and talk about some other forms of an equation of a line. So this is what we call the point slope form, because we can use the slope, which is m again, and if we know any point, doesn't matter, any one point that is on the line along with the slope, we can use in this formula to plug it in. And so our last form of an equation of a line is what's called the standard form. Now, we use the standard form for two different things. The first thing is to solve systems of linear equations. And so we will see some of this later on in this particular video series. But in short, we do problems, and I'll give you a quick example here. So let's say if we did x plus y equals 8 and x minus y equals 6. Here, both of these are lines, and what we're actually looking for is a place where these two lines intersect. Okay, and we do the standard form because in this form it allows us to be able to do either the substitution or elimination method, preferably the elimination method of solving systems of linear equations real easy. The other reason or purpose of having the standard form is that it quickly allows us to be able to find out what the x and y intercepts are for a particular line. So if we take the line that we have up here and I write it in if I write it in standard form, it would look as follows. We would start off by just saying y is equal to negative 4x plus 2, and to get it in this standard form here, we know that we would have to add 4x to both sides. So doing that would give us this situation. Now, of course, Here, if we want to find the intercepts, what we need to do is let x be 0 one time, and then the other time let y be 0. If x is 0, then we know that when we plug in x here, 4 times 0 is 0, so this whole term gets covered. And so we just have y equals 2. So we know that our y-intercept is at 0, 2. If we want to find the x-intercept, we let y equal 0. So we cover this whole term up. And what we see we have left is 4x equals 2. So 4x equals 2. And of course, if we divide both sides by 4, we would get x is 1/2 after we reduce 2/4. And so this would be our other intercept. And so we can easily just cover up terms. So here, covering up this first term to figure out the y-intercept, and here covering up the second term to find out the x-intercept, to be able to quickly sketch a graph of this particular function here. So now let's switch gears here and talk about the various types of lines that we have. So if we're considering some random point A, B, where A is representing the x-coordinate and B is representing the y-coordinate of a point on the line, then we know that if our line looks as if it is increasing, which means coming down to up like that, then we know we're dealing with a line that has a positive slope. And of course, equation of a line will look like y equals mx plus b. If we're dealing with a line with a negative slope, then it looks like it's decreasing. And of course, same thing. If our line is horizontal like this, then we know that the slope of the line is 0. And so this particular fact, being that a line is horizontal and the slope is 0, are inextricable, meaning that if one is true, then the other must be true. They go together. So anytime we find a line that has a slope of 0, we know that it is a horizontal line. And anytime we find a horizontal line, we know that the slope of that line is 0. So moving on to the last case is when we have a vertical line. When we have a vertical line, we see that the slope is infinite. And so you can think of this as if you were trying to drive a car on here. So of course, if we had, I'll draw a little car here. If we're trying to drive a car up a wall that is vertical, we know that the car's not going to get too far before it actually falls over. And so hence why we call this, in layman's term, a line that has an infinite slope, because nothing could stay on it. Everything would just slide straight down. Now, whenever we talk about the equations of a line for both the horizontal line and the vertical line, we have to pay attention to what's going on here. And so there's a very simple way to get the equation of the lines here, but we need to make sure that we don't overcomplicate the situation. So in short, a very quick way to remember is that if you have some point A, B here, and you know that you're dealing with either a horizontal or a vertical line here, X will always go with the vertical and Y will always go with the horizontal. So as an example, let's say I have some point 1, 1 here, and if I draw a vertical line that goes to that particular point, it will look like this. And this will be the equation x equals 1. And we know that because for every point that is on this particular line, we know that there is going to be an x-coordinate of 1 no matter what. So if we plot some of these points here, we'll see that we have the point 1, 0, 1, 1, 1, 2, 1, -1. Okay? If we were doing a horizontal line, a line with a slope of 0, it would look like this, and our equation in this case would be y equals 1. Okay? And so again, for the horizontal line, we know that it's horizontal because no matter what x is, the y coordinate is always 1. So we have a point here, 0, 1, 1, 1, 2, 1, -2, 1. And so when we're faced with having to graph lines, such as if we were talking about y equals -8, or let's say x equals +2, we know that x equals +2 will be a vertical line where every point on that line will have a x coordinate of 2. And for y equals -8, we know that that would be a horizontal line where every point on that line has a y coordinate of -8. So now that we know the basics about the different forms of an equation of a line, as well as what the various types of lines look like in terms of slopes, let's go ahead and do some practice here by graphing a line by using this equation of a line to plug in some x values for it. So to get started here, let's work on number 1. So for number 1, we want to find some x values to plug in so that we can end up with some y values here. So let's take it easy here and let's do -1, 0, and 1. Okay. So here, when x is a -1, of course, for y, for number 1, we have 2 times a -1 plus 3. And so 2 times a -1 is a -2. Add that to 3 and we get a +1. So our result is the point -1, 1. When x is 0, we know that by definition, when x is 0, then what we're going to find is the y-intercept. So we can see here that that's going to be 3. But I'll just go ahead and write out everything to make sure that we're clear. So we had a point 0, 3. And so now, when x is equal to 1, we just plug in 1 for x, and we see in this case, we're going to get 5 as a result. Now, when graphing these lines, we only need 2 of the 3 points, but you can choose which 2 you're going to do, okay? You can also plot all 3 if you want, and that's what I'm going to do here. So we have the point 0, 3. I'm going to plot that one first. So 0 units in the x direction, 1, 2, 3 in the y, and we have this point. Then after that, we're going to do -1, 1, which would be right here. And then we're going to do 1, 5, which would be 1, and then 1, 2, 3, 4, 5, right here. And so now that we have these particular points, we can just draw our line through here and graph. Okay. So we're going to do a similar thing with problem number 2. So we'll come here, make our t-chart, and then here, since we have this fraction, to get some nice whole numbers, since our denominator here is 2, we want to pick values of x that are factors of 2. So I'm going to start off doing 0, and then 2, and then 4. So if we go here, when x is equal to 0, of course, by definition, that's going to be the y-intercept again. And that answer is just going to be a -1. But I'll go ahead and write it out for clarity here. Okay. when x is 2, we'll plug in 2 in for x. And we know that 1/2 times 2 is 1, and minus 1, and that'll give us 0. So we have the point 2, 0. And notice that when we do this, this is actually the x-intercept for this particular line. And lastly, we'll go ahead and plug in 4. So we have 1/2 of 4 minus 1. And so half of 4 is 2, minus 1 is 1. And so now we can plot these points. Our first point, 0 units in the x direction, -1 unit in the y direction. And then we have the point 2, 0, which is here, and then the point 4, 1, which is here. And we see that in this instance, when we draw the line, we have another line that has a positive slope, just like the one that we worked on before. So now let's move to do some other examples. All right, so now we have two fresh examples here, and we see that our first example is the equation of the line y equals -3. So in noticing that, we know that we don't have any part here for the slope or x. So what that is telling us is that this is a horizontal line. And we know this because no matter what x is, the equation is saying that y has to be equal to -3. So of course, if we're trying to come up with some points for that, that would be rather easy. So let's say if I wanted to come up with 3 points, it doesn't really matter what x is. So I'm going to say let x be -1, let x be 4, and let x be 5. So if I do that and I plot, then -1, go 1 unit in the negative x direction, and then down 3, 1, 2, 3. So we have this point. We also have the point 4, -3. So 1, 2, 3, 1, 2, 3, 4 in the y direction, and 1, 2, 3 in, 1, 2, 3, 4 in the positive x direction, and then 1, 2, 3 down in the negative y direction. And of course, 5, -3 would be right here. And when we draw the line, you'll see that in order for the line to go through all of these, it would have to be horizontal. If we look at example number 4, we see that this says x equals 6. And so what this is telling us is that it doesn't matter what x is, it doesn't matter what y is, x is always 6. So here, what we can do is get 3 points, and we can just make up some values. So let's say 0, 2, 4. So no matter what y is, x is always going to be 6. So if we go here to try to find the point 6, 0, 1, 2, 3, 4, 5, 6. So this is the point 6, 0. If we move up 2 units, that's the point 6, 2. If we move up 2 more units, that's the point 6, 4. And as you see, the line that would go through all these points has to be vertical. And we know, again, that vertical lines have an infinite slope, or what we like to call undefined, and horizontal lines have a slope of 0. So with the ending of this example, this ends our lesson on graphing the equation of a line by plotting points.